Lecture 5-2 AC Circuit Analysis Superposition. Students should be reading section 9.7 of their textbook and pages 38 to 40 of Professor Griggs' notes. Upon completion of this lecture, students should be able to apply the principle of linearity or superposition to solve AC circuits for voltage and current when there are sources with two different frequencies or two different sources in an AC circuit. Superposition is based upon the principle of linearity and is used to find unknown voltages and currents by summing the contribution due to each independent source applied on its own. To apply superposition to solve a circuit, turn on each independent source one at a time, solve for the voltage or current, and then add them all together to get the total voltage and current. When it's two different frequencies, you have to do it in the time domain and show that those values were found at different frequencies. Note that you should never turn off a dependent source when applying superposition. Only use superposition to find unknown voltages and currents. Never use it for power. Power is not a linear property with respect to impedance or resistance. Example 1. So here we have a circuit in the time domain with two different sources, one at 2 radians per second and the other at 10 radians per second. So we need to redraw this circuit twice, once in the frequency domain for 2 radians per second and then again in the frequency domain for 10 radians per second. And since we're using superposition, we're only going to have one source on at a time. So when we have the left source on, then the impedances will be based upon 2 radians per second, and we will replace the right source with a wire. So the impedance of the inductor is going to be J omega L. So that one would be J2 ohms. The impedance of the capacitor would be negative J over omega C, so negative J over 2 ohms, and the resistor is 1 ohm. And note that the voltage source is one angle negative 90 because it's a sine, not a cosine. For the right circuit, for omega equals 10 radians per second, now we have one angle negative 90 degrees for the source on the right, a wire for the source on the left. And the impedance of the capacitor is negative J over 10 ohms. The impedance of the inductor is J10 ohms, and the impedance of the resistor is 1 ohm. Now we can use KCL in order to solve for IX. So we make that top middle node VA or VB respectively. And for the left circuit, we'll have a KCL equation, VA minus 1 angle negative 90 degrees over J2 plus VA over negative J over 2 plus VA over 1 equals 0. And we get that VA is equal to 0.277 with an angle of 123 degrees, and the units are volts. IX would be VA divided by negative J over 2. So IX is equal to 0.554 with an angle of negative 146 degrees. So KCL for our second circuit is VB minus 1 with an angle of negative 90 degrees over 1 plus VB over negative J over 10 plus VB over J10 equals 0. So VB is equal to 0.1 with an angle of negative 174 degrees in volts. And IX is equal to VB over negative J over 10, which equals 1 with an angle of negative 84 degrees, and the units are amps. So recall that since we got these values at two different frequencies, we cannot express the answer in the frequency domain. We must express the answer in the time domain. So we can now write IX of t to equal 0.554 cosine 2t minus 146 degrees plus 1 cosine 10t minus 84 degrees, and the units are amps. Example 2. For the following circuit, find V naught of t if Vx of t is equal to 10 cosine 2 pi 100 t plus 30 degrees, and V2 of t is equal to 5 cosine 2 pi 250t minus 60 degrees. So once again, we have the source at two different frequencies. So if omega equals 2 pi 100, the impedance of the inductor is J 2 pi 100 times 100 milli, which is J 30 pi ohms. The impedance of the capacitor is negative J over omega C, or negative J over 2 pi 100 times 100 micro. So the impedance of the capacitor is negative J 50 over pi ohms. So now for just the right source on, omega equals 2 pi 250 radians per second. So the impedance of the inductor is J 2 pi 250 times 100 milli, or J 50 pi ohms. And the impedance of the capacitor is negative J over omega C, or negative J over 2 pi 250 times 100 micro, or negative J 20 over pi ohms. So we're going to do KCL at V0. So let's draw the circuit with only the left source on. And the value of the left source is 10 angle 30 degrees, J 20 pi ohms for the inductor, negative J 50 over pi ohms for the capacitor, and 10 ohms for the resistor. And V0, using the voltage divider, is 10 in parallel with negative J 50 over pi divided by J 20 pi plus 10 in parallel with negative J 50 over pi times the source, which is 10 angle 30 degrees. So when we solve, we get that V0 prime is 1.44 with an angle of negative 85 degrees. We use the prime to distinguish the left frequency from the right frequency. So then we do the voltage divider again for our right circuit, where the source that's on the right is 5 angle negative 60 degrees. And we get that V0 double prime is equal to 10 in parallel with J 50 pi over negative J 20 over pi plus 10 in parallel with J 50 pi times the source, which is 5 with an angle of negative 60 degrees. And when we solve, we get that V0 double prime is 4.34 with an angle of negative 26 degrees, and the units are volts. Remember, we cannot add this together in the frequency domain, so we must state the answer in the time domain. So we get that V0 of t is equal to 1.44 cosine 2 pi 100t minus 85 degrees plus 4.34 cosine 2 pi 250t minus 26 degrees, and the units are volts.